Hi class, my name is Ayel Tarshanian, and I was in charge of doing the synthesis as well as the mechanisms for forming our ethyl benzoate molecule. So first, through our mass spec, we were able to find out that the benzene ring was monosubstituted. So with that, we used Friedel-Crafts alkylation. We did CH3Cl and AlCl3 to form our benzene ring and a methyl group attached to it, also known as toluene. We then use potassium permanganate and heat to form a carboxylic acid attached to the benzene ring, also known as benzoic acid. And then we finally use Pfister esterification, which is an acid catalyzed reaction where carboxylic acid reacts with an alcohol in the presence of an acid catalyst to then form an ester. So here our acid catalyst was H2SO4 or sulfuric acid, and our alcohol was ethanol. And then we finally get our ethyl benzoate molecule. So the first step in our mechanism was Friedel-Crafts alkylation. So here we have our alkyl halide, CH3Cl, and then our catalyst, which is AlCl3. And then a real quick review, the first step of this mechanism is to form an electrophile. So once we do so, we have our electrophile, which is then our CH3 positively charged. And then we also have the formation of AlCl4, which is a negatively charged. So here our benzene ring is going to go and attack the positively charged CH3. And then through resonance structures, we have movements of the positive charge around the ring. So in the first resonance structure, we have a positive charge at 12 o'clock, and then at 8 o'clock, and then finally at 4 o'clock. We then bring in our AlCl4 negatively charged molecule. It's going to come, attack the ring, remove the H, that bond then collapses, and we have the formation of our benzene ring and a methyl group attached to it, also known as toluene. Once we have toluene, we can then use the mechanism of oxidation of an aromatic alkane, and here we use permanganate and heat to then form a carboxylic acid. So then just going a little bit more in depth of the same process, we have oxidation of the benzoic position. And then real quick review, benzoic position is one step away from the benzene ring. So here the CH3, the carbon, and all three of its H's are all going to be in the benzoic position. And then we can use oxidizing agents such as permanganate, potassium permanganate, and dichromic acid, water, and heat to form a carboxylate. And then we're going to protonate that negatively charged oxygen with hydronium ion. We're going to have a loss of water, and then we're finally going to form our carboxylic acid attached to our benzene ring, also known as benzoic acid. Now that we have benzoic acid, we're going to go through Pfister esterification, where we're going to use H2SO4 to protonate our oxygen. We're going to have a loss of HSO4 negative, and through resonance, we're going to move the positive charge from the O to the carbon. Now that we have a strong electrophile, we're going to bring in a weak nucleophile, which is going to be our ethanol, to come in and attack that carbon and then attach itself right to it. And then here at the top, we have the same molecule as before being shown. We're going to bring in the HSO4 negatively charged molecule that we had just lost. We're going to come in and deprotonate the positively charged oxygen. Here, we're going to have a loss of H2SO4, and that's going to lead us to our resting intermediate, where we have a 50% chance of protonating the top OH, and then a 50% chance as well of protonating the right OH group. So I just chose to protonate the top OH. We do so by bringing in the H2SO4 that we had just lost. And then we're going to have a loss of HSO4 negative. This is then going to cause a really good leaving group. So it's going to form the loss of H2O, which then through resonance brings the positive charge to our oxygen. We then bring in that same H2O that we had just lost, and we finally form our ethyl benzoate molecule and have a loss of hydronium ion.